So, today we'll be talking about energy first. We have kinetic energy, which is energy in motion. And then we have potential energy, which is energy that is being stored. A way to remember kinetic energy is by a moving car. So, like, as my little model here, it's just a good way to remember kinetic. And then by potential, it would be the ATP diagram as well, which would be two adenosines, one ribose, and three phosphates. Secondly, we have the laws of thermodynamics. Energy cannot be created nor destroyed, and energy also is always transferred or transformed. Those are the two laws. And then we have, thirdly, the ATP, ADP, and AMP. First one stands for adenosine triphosphate. Second one stands for adenosine diphosphate. And the third one is adenosine monophosphate. On hydrolysis is basically the same thing as dephosphorylation, and it would be losing a phosphate. And then on phosphorylation, it would be gaining a phosphate. Then we have endergonic and exergonic. Ender means enter, exer means exit. Endergonic is also gaining or absorbing energy, and exergonic is also releasing or losing energy. Right here on this model, I have a model of substrate, active site, and enzyme. As you can see, this one right here would be a substrate. This pink line right here would be considered an active site. And this big green part is considered an enzyme. I'll be explaining these three things, which I will do right now. Enzymes are just proteins that are sped up reactions. Or enzymes are just proteins that speed up reactions. A substrate is a base layer that connects and grows onto the enzyme or attaches itself to an enzyme. An active site is that little pink area, and it binds itself towards the substrate together to make an enzyme substrate complex. On the next one, it would be factors influencing activity. First, we have temperature and pH. The temperature is too hot, or pH is too acidic. It can alter to change the shape of the enzyme. And then we have an inhibitor, which can block an enzyme. And the activity is temporarily or permanently. This big yellow thing is considered my inhibitor. Then we have cofactors and coenzymes. First, a cofactor would be this thing right here. It's a molecule or an ion that is required for an enzyme to function properly. And then this thing right here is a coenzyme, which is an organic molecule that is usually made of vitamins. Then we have competitive versus allosteric inhibition. Competitive is just a molecule that looks like a substrate or competes for the active site. And then the inhibition is just the inhibitors that attack a different site or changing its shape. Then we have redox, which in class, we learned that red means reduction and blue means oxidation. We also learned that reduction also means gaining electrons, and then oxidation means losing electrons. And then lastly, for an example, you can remember an OREG, which is right here. Oil would mean loss, which is oxidation, and then reg would mean gain, which is redox. I'm pretty sure I've covered everything. Hopefully y'all enjoyed.